Today's world demands a microservice-based POS design. This video is going to give you some concepts around what you need to do to build that microservice POS design by the Wizard of POS. Integrating a POS application prior to microservices was basically one big behemoth. Everything was an application that had to run locally or through some network connection to a local-based application. So what happens when you change the POS? A headache occurs. It's pretty complicated, and you've got to make sure you maintain connectivity to all of the applications connected to it. So what happens if you want to add a new scale? Same problem. You got to make sure you can connect to it and it doesn't mess up that which already exists. Or how about adding a loyalty card? Again, the same issue. In today's microservice infrastructure, it allows you to separate the application from the infrastructure. This allows the application to be run anywhere without any knowledge about where it's being run. And it allows the infrastructure to place the application anywhere without knowing the internals of the application. And so the infrastructure is a separate entity from the application. The beauty of the Microsoft network model allows each individual application to be upgraded independently. You want to add a new loyalty system, you simply replace it without impacting any of the others. How about a new scale, a new piece of hardware on there? Or maybe a new payment application you want to integrate with somebody's payment service. Or finally, maybe you want to update the POS application itself independent from all of the other applications within the store. So what are the components of a microservice application? Well, first you have the service itself. This is the actual code that does the implementation of whatever it is you're trying to do. Inside of that, it's set in a container. That container is now what the infrastructure can move around and put anywhere. And you have an interface. It's an API definition. This is where standards interfaces become huge because it allows you to interface without knowing anything about any other application. So let's look at the microservice model in action. So first it starts with the microservice itself. It gets put inside of the container. And if you have two microservices that need some close connectivity for some reason, you can put those into another container called a pod, in which case both of those get put together. Then you have the data model, which is a key component of the microservices world, so that all of the things talk the same languages. Has a registry which locates where this instance of that microservice gets stored. And then if there's any sort of translation that occurs, there's a translator microservice for managing that. Now you want to ideally minimize this by using standard API interfaces. So let's take a quick look at a microservice interface timing diagram for a retail transaction. It starts with a transaction begin. You scan in a data through a data add. You add line items by adding lines. They then interface to the various engines for calculating price and getting item information. You add in customers, looking up customers, and any sort of associations that can occur. You total the whole thing, and you can then calculate the tax with the tax engine. You decide you want to tender it. You can now pay for it with a gift card or with a credit card. And finally, the transaction is finished and closed. Each of these become separate microservices in and of themselves. Cash registers began as cash boxes, simply a cigar box that was put on the counter to keep the money in. Unfortunately, it wasn't very secure and a lot of money disappeared. So along came a cash register. This was in the early 1900s, and it was primarily focused as a way to secure the money. Today, that system has expanded dramatically. So in addition to the sheer number of store systems that use POS information, the POS itself has migrated to almost anything you can sell through. This is where the microservice model shined, by allowing one to sell in any way they wish, through whatever kind of model they wish. This is a sample of the various systems that have to run just to sell items. You've got tax engines, item engines, inventory, time punch for the worker to sign in and out, unified POS for the various devices, and we'll see those in a minute, various cash management, customer, tender, kitchen, price engines are involved. It's very complicated. If you have a large number of stores and try to upgrade each store under control, that means that some stores will have version 1 of an application, maybe a payment application, while others will have version 2 of that same application. And it gets even scarier when you add multiple vendors upgrading their software independent of other vendors, or worse yet, you start changing software from one vendor to another. Well, doggies, that sure looks complicated to me. So let's make it even more complicated. There are 35 different devices in the Unified POS standard model that can allow you to connect to the various systems. So on top of all of those applications, you've got the potential for 35 Unified POS devices. And their latest one is a set of schemas around robots and being able to control the robots inside of the retail environment. So let's just take a quick look at some of those interfaces in the stores that you have to connect to. Starting at the top here with a video interface, being able to hook up to a camera to identify customers and watch for loss prevention. You can have a call center interface, which is hooked up with a self-service order interface, or SSOI. You can have a remote order display interface, again, SSOI. People can order from their homes on a website using the SSOI interface. You can send a digital receipt to them so they don't need a paper receipt. This was quite popular in Japan, and it was mandated for the 2020 Olympics. They can order from their table with their tablet or their cell phone using, again, the SSOI interface. You can communicate to all of the 35 devices we just saw using the Unified POS interface. POS Log, which is one of the most popular interfaces of all of them, allows you to communicate all over the world, and in this case, showing it's communicating to corporate about what was sold there. You can communicate with the kitchen equipment, being able to monitor their status and what's going on with them and send orders over to them. You can also talk to kitchen devices like the remote order confirmation board or the bump bar using, again, the Unified POS interface. You can order to a kiosk in a drive-through using, again, the SSOI. This just is a small sample of all of the various interfaces that you can use that are in the standards model. So I regularly get questions about the API schemas that are in all of the standards models because the schemas themselves are quite large. And they want to know, do they have to send all of that information whenever they're communicating back and forth? Or do they just need to be able to send a message subset? The point of this slide is to show the sheer number of different systems that have to integrate with POS information. This is maintaining all of these interfaces independently is a monster. In addition, there's an enormous amount of information being sent between all of these systems. For example, POS log. Oh boy. This is the POS log schema. And there are two pieces to a message, the schema and the message itself. The schema is huge because it completely covers the domain it's trying to communicate about. It sets a standard so both ends can clearly communicate using the same terms in the same location within the message. However, the message itself doesn't have to use the entire schema. It may only need to use parts of the schema that apply to this message. Furthermore, each of these nodes only need to contain relevant information for this message. In this example, the highlighted efforts are the nodes necessary to sell an item. In the end, the schema is large. In this case, POS log has got over 5,000 attributes in it, but the messages themselves are relatively small. So what are the standard schemas I need to be able to communicate in a retail store? Well, at omga.org/retail, there's this entire inventory of schemas that comprise over 80 to 90% of the interfaces in a retail store. Thank you. I am the Wizard of POS. My name is Richard Halter. Please check out my book, Art for Retail, Using Technology to Turn Your Consumers into Customers and Make a Profit. It's available on Kindle. Thank you.